No problem. Talk in English only. अच्छा. So wait one minute. You have given me one question. You've given अच्छा, this question. Okay.
I just have like problems with spring questions. I'm not able to do them.
The spring question you have doubts. You have problem.
Like all of the questions that I sent, 23, I just have a doubt in one of the options. Rest, the
What
other four.
is? This question was actually the question that 23rd one. Na? I think this question has been asked in JEE previously.
Oh,
It's actually not that difficult. It's okay only. 24th. Achha, what about 24th? Sister, यहाँ is in this. What
I
problem
didn't
you faced?
understand what to do.
Achha, you did not understand what to do. Okay, let's study it then. In the situation shown in figure, the ground is frictionless. The ground is frictionless. Find the maximum extension of the spring if the blocks are initially at rest with spring in natural length. The situation, the ground is frictionless. Find the maximum extension of the spring if the blocks are initially at rest. The spring is of natural length. The forces are given. If you see this one, see actually what we can do here in this question situation is given like this. There is this block,
So which one?
the first one that you have given, no? The 24th one.
Okay.
24th one that you have given.
Yeah.
This what is there? Let me see. Wait. The blocks are like this. This is your first block, and this is the spring, and here is another block, and they are actually present on the surface. The force is 3F, and this force is F acting towards left. This mass is 2m and this mass is m, and there is spring constant K like this. Maximum extension of the spring they are asking. So what we can do is we can take it as one system, as a system in which we can take it as a system in which both the forces are acting only on one side.
Okay.
F net, and we'll take it. These both masses are there, I'll assume this as like this. This is a fixed part and this is a spring, and the net, there is this mass, this is 3m. अच्छा ऐसे नहीं, like this we cannot do it. On this system, if we take the two masses system, there will be net force which is acting in the right direction, which is 2f. 3f minus f is equal to 2f. And if we the this system will be actually moving in the rightward direction with some acceleration, right?
Yeah.
Because and the acceleration will be 2f divided by 3m, which will be a. This should be the acceleration of the center of mass. Now the blocks are initially at rest. They have told us being within natural length. When will be the maximum acceleration? When will be the maximum expansion? The maximum expansion will be, acha, if you see, this is the acceleration of center of mass we have found. Initially they were at rest. This is u is equal to 0. This is also equal to 0. And first we have to find out at what point they will have the maximum expansion. So the maximum expansion, see, if they both are moving, they both start moving with the acceleration, because this is the acceleration, acceleration of center of mass. They both will be moving with some acceleration. Means if at any point, the x, suppose the expansion in this is x, then there will be force here. If this is compressed, there will be force here with this kx will be acting like this. There should be another force which should be acting like this, kx situation. How do you approach this? Suppose this is moving, the situation is when this is moving with velocity v1, this is moving with the velocity v2, and this is higher, u1 is greater than u2, u1 is greater than v2 initially, suppose. Let's say it is u2, u1 is greater than u2, suppose. Then it will be compressing. That's not the situation of maximum expansion. Then at a situation that velocities will become equal, u1 will become equal to u2, and then what will happen? Then u1 will be decreasing and u2 will be increasing. u1 is more than u1 will be decreasing, And sorry, so let me analyze it. See, first I am taking the situation that when initially, suppose u1 is there, this is u1, this is u2. If suppose u1 is greater than u2, in that situation, this will be compressing. It will be, the spring will be compressing, and then at an instant their velocities will become equal. u1 will become equal to u2, and then after what will happen, then if suppose then also this is increasing, no, u1 is more than this, u1 is decreasing and u2 is increasing, then this situation will arise. After that, what will happen? u1 is further in decreasing. u2 will then okay. See, Trista, what will be the situation now? The situation is they are asking you the maximum extension of the spring. Initially they are at rest. We have to find the maximum extension of the spring. Maximum extension of the spring will be in a situation when the velocities of both the blocks will become equal.
Why?
See, just analyze like this. If you take any random situation, they have started moving. Initially they were at rest. They have started moving, and when they have started moving, suppose you take initially the u1, if you take this velocity u1, its velocity as u2. I'm taking a random situation, taking u1 is greater than u2, correct?
Yeah.
Okay. Now what happens? If suppose u1 is greater than u2, u1 may keep on decreasing. u2 may keep on increasing, because why? Because u1 is greater than u2. This is actually compressed. The spring is compressed. Okay. Relative velocity is towards right now. It's compressing. Right. Now what will happen? There will be and then what will happen? Because u1 is greater than u2, u1 will keep on decreasing because spring is compressed. If you stop the right block, small m block, and take the relative motion of 2m, the spring is compressed, so the spring will try to expand like this, okay, backwards. So what spring will do? Spring will actually try to reduce the velocity of u1 and try to increase the velocity of u2. Correct? Okay.
Yeah.
So then there will come a situation when u1 is decreasing, u2 is increasing. There will come a situation that velocities of both will become equal. Okay. When velocity of both have become equal, then what happens? Then after that, this again starts to expand. If it does so, the velocity of u2 is increasing. u1 they have become equal. At that point, what will happen? The u2 will start to decrease, and again u1 will start to increase.
Why does that happen? Like, why doesn't u2 increase and u1 continue?
It cannot keep on doing this now, because they both are moving. Now when u2 has increased and u1 is less, means suppose this situation has arisen, this situation is there, both the velocities are equal. Now if you increase this velocity again, this rightward velocity, if you again increase the velocity of small m and it is less, then again the same situation will arise, na? The same situation that originally was.
Yeah.
It will start to compress again. Means because the relative velocity will be there. Relative motion has started. So the velocity of whomever, the velocity of m is more, then it starts to compress it again from that situation towards left. Initially the compression was towards right. Now the compression will be towards left.
Oh. But after both the velocities are equal,
No.
the 3F forces.
Tell me.
The 3F force is still more, right? If it's accelerating more, why won't that only have more velocity at the end?
No. Forces are actually acting. I'm just explaining you the situation. There may be a situation that the forces are always there. There may be a situation that the velocity of m initially was more than the velocity of 2m. It can happen like that.
Yeah.
Okay, that depends on the acceleration. If you talk about this the acceleration of this small m, it may be greater than this the acceleration of this 2m, because the mass is less. Okay, so the velocity of m will be initially higher when it starts its motion.
Okay.
But again, initially I have taken the reverse case, but this initially, if according to this, u2 is greater than u1 actually. So it will start to compress leftwards because the relative motion is towards left.
Yeah. Okay.
Okay, so there will be a situation that u2 will keep on decreasing and u1 will keep on increasing, and then there will be a situation that both the velocities become equal. And when both the velocities become equal, again the velocity, again after this, the maximum situation has been occurred where they can have maximum expansion. After that, again the relative motion will be there, and in that relative motion again the spring will try to compress.
Okay.
Understanding?
Yeah, but won't the maximum case be when both the velocities are in opposite directions?
But
Like,
you have to analyze this now, whether it's possible or not. Is it possible?
I don't know, like U1 backwards and U2 forward. So extension on both sides.
But you have to see whether it is possible or not. If this is possible, if that is possible, in that case maximum expansion will be that situation only, when both are going reverse.
Okay.
But here in this case, center of mass, we have to take the expansion of each. But how I'm going to apply this one? Let me analyze it in different way. This is the situation is like this. You are saying that it will become maximum when they are moving with opposite velocity, and that too that the situation when they will have the maximum expansion, in that case their velocity momentarily must become zero, not equal. Momentarily,
Yeah.
this must become zero, na? I like that also. We can think means their velocities are equal, or relative velocity is zero, or their each velocity momentarily becomes zero. That also you can do. Acha. Okay, let me do it. You have the answer with you, na?
Only the answer, yeah.
Okay, let me do it. Let me see whether we are able to solve it like this. This is, suppose the displacement, this is the force F, this is spring, and let me have the center of mass here, and this is small m, this is acting with this 3F force, center of mass is somewhere here, and let us have the situation, the expansion in this is x1 from the center of mass situation, and the expansion in this is x2, suppose. And in this particular case, the center of mass is moving with this one. So initially they were at rest. This velocity was zero, this velocity was zero, and finally when the maximum expansion situation is there, their velocity finally should also become zero. This also should become equal to zero. Then in that case, If we apply the work energy theorem, then in this situation, the work done will be F into x1 F into x1 that works plus 3f into x2 is equal to half k x square, which is x is equal to x1 plus x2. Okay, right now
Yeah.
this is a equilibrium equation. The work done is okay. Okay, so first this is first equation, and then this is second thing. Now acceleration of center of mass is only there 2f by 3m. Now if we talk about the center of mass displacement, this force is there. This force will be exactly at every situation. This force will be actually cancelled with this in this situation. And
We
this
can
also.
solve it in the center of mass frame only.
Huh?
We can solve it in the center of mass frame, right?
But how?
We, uh,
Center.
like on block M1, like
Hmm.
M, we can take pseudo force. So like net force on the block M would be 3F minus 2F by 3, 7F by 3. And shouldn't that be equal to Kx only?
No. In that case, you have to minus the x, means which force you will apply, means what pseudo force you will apply, what will be the acceleration of pseudo force, m into a.
Like, we'll take it in the center of mass frame, right? So M into A will be M into,
Acha, you will be subtracting that m into a with both the masses.
yeah, both the masses.
Then what you are trying to do?
After that, we have Kx acting on M, and
Hmm.
on the other side, it's 7F by 3.
Hmm.
Shouldn't we just equate them?
I don't think so. You will be getting the right answer there. 7f by 3. This is 3f. Do it. Try to do it that way and see you are getting the answer or not. 2m into x1 plus m into x2 divided by 2m plus m. This is equal to 0. So 2x1 plus x2 by 3 is 0. 2x1 is equal to minus x2. One plus 2x1 is equal to x. Plus x1.
Sir, I got the block on, the force on both the blocks is 7F by 3. So now I can do kx1 is equal to 7F by 3 and kx2 is equal to 7F by 3. And I want kx1 plus x2 only, right? Should that work?
See, we are getting a wrong answer, negative answer. I think this is x. 2x will be minus 5f by 3 is equal to kx by 2 equal to 10f by 3k.
Yeah, it comes.
It's coming.
Yeah, but
Acha.
I don't understand why we should equate the force. Like, why should 7F by 3 be equal to kx1? Why is the acceleration 0? Do both the blocks not move with respect to center of mass? Like,
Both the blocks move with respect to center of mass. Individually, see, if center of mass is moving, you can actually analyze the motion of each block with respect to center of mass. There is no harm in it.
no, like, should I take the velocity of, the acceleration of both the blocks with respect to center of mass is 0?
Acceleration of both the blocks with respect to center of mass is 0. Why?
No, I
No,
don't know. If I do
you
that,
cannot. No, you cannot. Because it's not necessary, na, Krista, that the center acceleration of center of mass, acceleration of each block with respect to center of mass will be 0. Acha, wait. Let me see. Uh, the
at
net
maximum
force
extension, it should be 0, right? That's
at maximum expansion it will be 0. But one thing is sure that because the net force at every situation is 0, center of mass won't displace actually. The net displacement of center of mass will be 0. Acha, tell me one thing, whether we are getting this answer. What is the answer? X is equal to 5 meter.
No, it's 7.
7.
Yeah.
But I am getting 5 actually. You are getting 7.
Yeah.
Tell me how.
I took pseudo force on both the blocks.
Hmm.
So on the right block, it's 3F minus 2F by 3. The
3f
force on,
minus. Okay.
which is 7F by 3.
Uh,
And on the other block, it's F plus 4F by 3.
f plus 4f by 3. Okay.
Which
7f
is,
by 3. Again.
yeah,
Hmm. Same direction or towards the left. Achha, towards the left it will be.
yeah, towards the left.
Towards the left it will be 7f by 3. Why it's same? Achha, same you are getting. So then what you did?
Then I did kx2 is equal to 7F by 3 and kx1 is equal to 7F by 3. And then I added them.
Actually, what you are doing, yeah, Trista, you are doing the same thing that I am doing this other way. You are also getting this the displacement of center of mass is getting 0, no? Because forces are equal.
Yeah.
Ah, but actually your concept is correct, not wrong. 7f by 3 should be equal to your kx2, right? So x2 is equal to 7f by 3k. Hmm?
So then
See,
the length of the spring will always remain constant only, right? If it's not
hmm,
displacing on either side. So then if I take any case like when the acceleration of both is 0, then
hmm,
I find the extension and that spring, it should work, right?
hmm. But x2 and x1 they both are this one only, na? 7f by 3k. So you are
Yeah.
getting 14f by 3k.
Yeah.
But actually, when I'm solving using this, I'm getting 10f by 3k. the concept that you are applying now. See what I did. This is 14f by 3k, which is again, if you do it, is you are getting the answer 14 into f is 3 na.
Yeah.
And what is this k? What is the value of k they have given?
2.
2. So 2 7s are 14, 7. This is one way of doing it. But if you do the same thing by other way, by using work energy theorem, na, see what I did. I have taken the displacement of the left block as x1, on which force F is acting. The right block is x2. I have found out the work and used the work energy theorem. Okay. Work energy theorem. So actually, law of conservation of work done by non-conservative force is equal to change in mechanical energy. It will be half kx square only. Correct. Now x is equal to x1 plus x2. Now because the center of mass, actually the net force in every situation, if you see, the 3f will be cancelled by the kx, and kx is also acting here on the 2m. Okay.
So when you apply work energy theorem, there's no change in kinetic energy.
No, because final kinetic energy is also 0 na. For each block, the momentarily they will be at rest.
Yeah. Okay.
So the display, I have actually done the both, they are expanding, so the displacement of the center of mass will be actually 0. And because see the situation you have got, 7f by 3, 7f by 3. In this situation, the net displacement, net acceleration of the center of mass will be 0. So the displacement of center of mass is 0 because the net force is not acting on the situation. So I have equated this with this. So I have got 2x1 is equal to minus x2. Then I have kept in this. And now I am getting x is equal to tan f by 3k. So I was getting 5 as answer. But there is no wrong in your this one way of solving. It's actually correct, not wrong. It's solved, na? Then.
Yeah.
Should we move on to the next one?
Yeah.
Okay. The next one is, usually in these kind of questions, na, this question is somewhat different. Usually, Trishta, in these kinds of questions, the maximum expansion occurs when the velocity of both the blocks become equal. Usually, when you see those situations, the forces are not acting. If the force have acted for once and then it has disappeared, because in this case the force is actually acting continuously. It's acting, keep on acting constantly, 3f and f. If the force was applied initially and then it was removed, then in that situation they have started to move. In that situation, the maximum expansion occurs when their velocities are equal.
So can you scroll back up once? So when you replace x1 by x by 3 and x2 by minus 2x by 3, why are we taking the minus? We don't need the direction, right? We just need the magnitude of extension. And then we'll get 7f by 3 also.
No. When we have applied, see, we do not know, but when I have applied this concept, now, this 2mx1, the displacement of center of mass is 0.
Yeah.
The center of mass displacement I have tried to find 2m into x1 plus m into x2 by 2m plus m. In that situation, I have found out that x2 is actually minus of 2x1.
So, but that's just direction wise, right?
It's just direction wise.
So when we're doing f dot x, we're already taking the direction, right? So shouldn't we like not take the minus in the extension?
If we were taking the this is x, like negative.
Like if you're taking 2x1 is minus x2, they're already taking x1 is backwards, so then the dot product should also be minus 1, right? F dot x.
Wait. I think this is the mistake that I have done. 2m into x1. This is towards the left. 2m into x1, m into x2. Correct. Let me check it once. Then I should get, this is a silly mistake I have done. 2m minus this, so x2 will be positive. In that case, you'll be getting 2f. Yes, Trishta, we have got the answer. Where you are? See, this was a silly mistake. Now me also got the answer.
Yeah.
That only I was actually not able to see where I have done wrong, because everything was correct according to conceptually. So whatever, whether you do by your method, whether you do by this method, you are going to get same answer. F is 3. F is 3, K is 2. Okay. Yes. Correct. So whether you do by that method or whether you do by your work energy theorem, both the ways you can get the answer. Both the ways you understood this method, na?
Yeah.
Okay, let's move on to the next one. The horizontal plane surface shown in the figure is such is rough with the coefficient of friction being all the points right. All the points right of P. Acha. It's rough only on this surface, only up to this surface. It's rough with a coefficient of friction mu for all the points right of P. Means from the P up to P, this is smooth, and then from P, the friction starts. The long massless spring of the case rest the wall of the free and is at a distance L from P. A block of mass M is given a speed U towards the spring. Let U not be the maximum value of U such that the block stops before compressing the spring. It is noticed that for all value of U less than alpha U naught, the block perpetually stays at rest with spring in compressed state. What is this question? Up till here it's clear. The block of mass M is given a speed U towards the spring from the smoother side of P. Yes, Trishta? This is moving with velocity U, na? Initially. U not be the maximum value of U such that a block stops before compressing the spring. Trista, just see. Your mic is mute.
Sorry, yeah.
See what they have told, na? U naught is the maximum value of U such that the block stops before compressing the spring.
Yeah.
That means the block is stopping just before it attaches to spring, right? This is what they are saying.
Yeah.
Then it's easy, na? Up to here we can find out the value of U naught by applying the work energy theorem.
Yeah.
It will be minus mu into mg into this L is equal to final minus initial. In final velocity is 0. It half into m into U naught square. What is the problem in this?
What do I do with alpha?
U naught square is equal to 2 into mu into g into L you are getting. This is cancelled. Then what he's saying? It is noticed that for all value of u less than alpha mu naught, alpha u naught, u less than alpha mu u naught, the block perpetually stays at rest with spring in compressed state. Acha. Find the value of alpha if mu mg by kl is equal to 2. Acha, just tell me what did you do with this question?
I stopped over here only.
Acha, you also stopped here. See, after this, if we this one, it is after this what they have told, it is notice that for all value of u less than alpha mu naught, alpha u naught, the block perpetually stays at rest. Means perpetually means continuously. Perpetual, yes, you know, perpetually stays at rest with spring in compressed state.
Yeah.
But how is it possible? If u is less, means acha, alpha may be greater than 1. Alpha u naught, the block. So for this, you will have to apply again the work energy theorem. Take this situation. Just let me analyze it. This is the block. This is that situation where spring has, and there's further in compression in the spring. Now the spring is compressed like this. Okay, now this is the L distance and this is the X distance. So the work done, now when it has compressed by X, here will be potential energy. So will work energy theorem minus mu into mg into L plus X will be equal to finally 0 because it's going to stop here. Finally 0, we have taken this velocity as u minus half mu square. Acha. At this situation, final situation, it has got some potential energy also. Acha. So I have to add here potential energy. Correct. Half kx square. Velocity is 0 minus, initially it was 0 plus half mu square. Simple work energy theorem. Okay? Okay, na? Now the relation that we will get is half mu square is equal to half kx square plus mu into mg into L plus x. Now what we have to do with this? U is less than alpha u naught. We have given u is less than alpha u naught. This value we have got. Because this friction goes will be opposing this. Acha, I'll stop. So x I'll put here, this one. half m alpha square, half m alpha square u naught square. U naught square value I am putting, it's 2 mu gl. Half k, x is mu mg by k. What they have asked. Find out the value of alpha. Mu mg by kl they have given. This equation we have to solve.
Yes, sir.
Actually, this equation we have to solve, because see, what I have done, because they have given if u is less than alpha mu naught, that means I have taken that case, means the threshold case that we take. Na? Suppose u is equal to alpha u naught. I have taken that case, because otherwise we won't be able to solve this question. And again, when it stops here, in this situation, the friction force should be actually balancing the kx. That's why it has stopped.
Yeah.
So I can just equate mu into mg is equal to kx. So the value of x, mu into mg by k I'm putting, and u as alpha square u naught square, but u naught square value we have already found. It's 2 mu mgl. Okay. So
So you
this
applied conservation of energy on which 2 points? Like the work energy?
conservation of energy I have applied between, see, the initial one, the initial when it just entered into the rough situation, the
Okay.
rough surface where it has velocity u, and the final situation when it has stopped after compressing, this one. Okay.
Yeah.
So this equation is okay, na? You understood how this equation is made?
Yeah.
Just the work done by non-conservative force is equal to change in mechanical energy.
Yeah.
And these things I am applying. Just now we have to solve this equation. Actually, it's, let me see, alpha square into mu mgl. Let me solve it. Mu square m square g square by 2k plus mu mgl plus mu square m square g square by k alpha square into, can we cancel out mu mg? Mu mg,
Yeah.
mu mg, mu mg. Yeah, we can cancel it out. But let me cancel it once I add them. 1 plus 1 by 2, it will be 3 by 2 mu square m square g square by k plus mu mgl. Now I'll cancel mu mg. Are we getting any answer? Achha, L also I'll cancel, then I'll put here.
Yeah.
So alpha square is equal to 3 mu mg by 2kl plus L I am getting. Achha, what they have given? Mu mg by kl. Mu mg by kl is 2.
Divide by L on both sides.
Huh?
But you divided by L on both sides, right?
Yes.
So it will be plus 1, not plus L.
Achha, L. Ah, okay. See, these kinds of silly mistake I do. Actually, when I do continuous classes, na. 1. Good. So it is 3 by 2 mu mg by kl. What they have given? 2.
Yeah.
2 plus 1, it will be 3 plus 1, 4. Alpha square is 4. So alpha is equal to 2 we are getting. Check.
They give 3.
What is this? Why? It's simpler question, an easier one. Why should there be a mistake here? Again, I think I have done some silly mistake. You notice 2 mu GL, so I've kept 2. Okay. Half, half. Okay. Half mu and GL. They have given 3.
Yeah.
So that means we should get alpha square as 9.
Yeah.
Where we are doing mistake. KL is equal to 2. This is only correct. I don't find any wrong in this. Just let me check once again the equations, or I have done some silly mistake. Mu into mg into L plus x. Okay. This is the work done. So this is half kx square. Okay. This is half mu square initial velocity. Okay. Final velocity is 0. Half mu square is equal to this. I have done this one into mg g into L plus x. X value what I have put? X is equal to mu into mg by k. Correct only. So so half into k into mu mg by k. This is works correct. Correct only, Drishta.
Okay, I'll ask my teacher if there's a teacher.
You just ask your teacher, sir, whether this is correct answer, and if he's getting the right answer, then just find out what mistake we are doing. What, okay? Because according to me, everything is right. We cannot do anything other than this because conceptually everything is right. Mg 12. That's a square. This 2 plus 1, 3 by 2. Correct only. Alpha is equal to 2 only we are getting. अच्छा. The ends of the springs are attached to this. The next question, 17th one.
Yeah.
The ends of the springs are attached to the block mass 3 kg and 2 kg. The 3 kg block rests on the horizontal surface and 2 kg, which is vertically above it, is in equilibrium. Okay. This is the situation. This is 3 kg and this is your 2 kg. 3 kg is on the floor. 2 kg is vertically above it, is in equilibrium. Compression of 1 cm. Acha. Compression of Acha. In equilibrium, there is a compression. X naught is equal to 2 centimeter. Sorry, 1 centimeter. The 2 kg must be compressed further by at least X centimeter so that when it is released, the 3 kg block may be lifted off the ground. Okay. Acha. What did you understand by this? The concept that you have applied?
First case, I applied kx equal to mg, and then I found the value of k.
Okay.
Now in the second case, they're saying that 3 kg is just lifted off the ground. So I just did that the normal reaction should be 0
Correct.
on equation. So I just did 3 mg is equal to kx dash.
The X that they have required.
Yeah. So, and it was already compressed by 1 before. So x dash minus 1. But I'm not getting the correct answer. Like doing that, I'm getting 1, but the answer is 3. And some people got the answer as 5 also. So it's either one of those.
Acha, so kx naught is equal to mg, which is 2g. So x naught is equal to, x naught is 1, k is equal to 2g, 200, 20. Kx naught is equal to 2g, so 2g by x naught. Okay. What is it? Pen got stuck. Arey? Wait. There's some problem with the pen. 2g by x naught. So this value of k we have found. So now it is, if it is x compressed by x, there should be this should be the amplitude compressed by x and then released. So x should be amplitude, and due to this there will be a force m omega square x. M omega square x should be equal to 3g for it to lift off. So omega is equal to, so when 2 kg block is moving, omega is equal to k by m, which is k by 2 m x into k by 2 is equal to 3g. What is m? K by 2m. To p by 4 What's the value of x? They've got 3 by 4. We'll be applying m omega square x on this. M omega square x p3 x naught by 2. X naught by 2 is x naught is 1 by 2 0.5. What is the answer?
It's either 3 or 5. I'm not
3 or 5?
like some people got 3 and some people got 5. I'm not sure what the answer is. But it's one of those two. But I don't understand what's wrong with my logic. Like, why can't I just do kx is 3g?
Kx is equal to 3g you are saying, na?
Yeah.
When it is compressed, by this, you are saying the force it's doing like this, doing SHM, Kx. This Kx, you can do Kx is equal to 3g, there is no harm.
But the answer is not coming with that.
Then in that case, you'll get x is equal to 1.5, right?
Yeah.
X is equal to 1.5 you'll get, and the x is equal to 1.5, then
-1.
-1 you'll get 0.5. X is 0.5, so one answer you should get, na?
Yeah, but that's not the answer.
What you said, what they are getting?
Either 3 or 5.
What the answer is given in the answer key? 3.
Yeah, 3 in the answer key.
By the other method also I'm getting this only.
One.
One only. I have applied m omega square x, that's a simple SHM, the normal SHM, na?
Yeah.
What I have done, because when it is, this is an equilibrium position. After this equilibrium position, this upper block will do SHM, up and down, like that. So because they have given it is further compressed by x, so this becomes your amplitude. By that amplitude, it is doing SHM, up and down, up and down. And it will be, and when this will lift off, when this 2 kg block is at this situation, 2 kg block trying to go up.
Okay, yeah.
Okay, and at that point, the kx, why your method and my method are same, because the force which is acting on this will be m omega square a. Okay, this will be equal to the kx here for this, and this m omega square a will be actually applying on this, correct? The lower block.
Yeah.
And this one which is through the kx actually. So for this 3 kg block, if you see, there will be m omega square a, and it will be opposing the 3g, so that it gets lift off, the normal reaction becomes 0.
Okay.
So that's why I have equated m omega square x with 3g. Now m omega square x, if we equate it 3g, we will get the value of x as 3x naught by 2m. The m value is 3 here for 3 kg, na? So
Yeah.
it will be 3 will get cancelled. X value will get as x naught by 2. Okay.
Yeah.
Hmm. Wait. 3 x naught by 4. 3 by 4 into 1. Hmm. But the m value we have to put as this is on this m omega square a. The force on this will be m omega square a. The m value you have to put as 2. So it will be 3x naught by 2 into 2. Acha, 3x naught by 2 into 2 means 3x naught by 4. So 3 by 4 into x naught is what? X naught is 1, no? What? Initially 1 centimeter. I'm getting totally different answer. 3 by 4 into 1 and this is x. 2x is 3 by 2. I'm getting 1.5, Vista. Not even
Yeah.
1. I'm getting 1.5. Because actually this is not this question this type of question I have solved earlier also, but the same concept, why the answers are different? Hmm. Acha, Trista, let me end the class because 1 hour class is there, no? One more
Yeah.
question is there, no? 18th one. I'll try to
Yeah.
solve it and send you. I'll check this one. Okay. You just check with your sir whether the before question that we have solved, the answer is alpha is equal to 2 we are getting now.
Yeah.
And look at the solution also how he has done. Because according to me, the answer should be this only. Okay.
Hi, sir, this is Trishta's mother.
Yes, ma'am.
Yeah, just one thing I wanted to say. Is it
Hmm.
okay that going forward, Trishta will send you the questions a little in advance so you could just look at those questions and in the class then you can discuss the solutions and the approach to the.
That is also okay.
I'll ask her to send the questions in advance to you. Sure. Thank you.
Bye, sir.
Bye.